Okay, so let's resume. So we have seen the example like how we can use the adjacency segment, and then using the adjacency segment we can use the link. Even it will have a higher metric, but we will be able to force the traffic. So the traffic will go over the specified link, like in this case the metric is 100. So using the shortest path it cannot go over the link from P5 to P6, but since we are specifying the instruction for the adjacency segment, it will go over this link. So the next we have, this is like how we can do the traffic engineering, where we have to use the AnyCast seed. It's like the node seeds, but in case of AnyCast, same seed is used to reach to multiple nodes, and either one of them that can actually forward the traffic once it receives. So this is our topology. In this case we can see we have two set of routers in the core network, like we have same P routers and then P router as well, but we have two groups of Anycast group 1 and then Anycast group 2, and their IP address is for all these nodes it's 113.1 and this is 113.2, and the SID is 100 and 200. So in this case since they are using the same SID, that means if we will send the traffic using the 100 from P1, it will go to router 1 using the shortest path. Then from router 1, based on the metric, it can go to A1 or A2, to either one of them, and once they receive it, they can then forward to R3, they will forward to A3 or A4 depending on the metric inside, and then it will reach to R2. So that means same SID we can use for all these of nodes. If traffic is coming from the right hand side, P3 it's going to send traffic to R3, and the SID is 100, so it can go either to A3 or A4, and then they can pass the traffic to the left hand side. Okay, so when we are saying Anycast SID, that's mean the node A3 it is also using SID 100. Node A1 it's also using SID 100 to identify itself, and node A4 it's also using SID 100. A2 is also using SID 100. So the example for this in network, it could be like the root DNS or the DNS server. So sometime you have your DNS server or the root DNS, they are using the same IP address, but they are being deployed like in multiple cities, in multiple countries or continents, but their IP address is same. Maybe you have noticed like the IP address for the Google DNS, it is even used in Pakistan or used in other country, it is same, like 8.8.8 their public DNS, and other one is like maybe 4.4 and 4.4.8. Similar for Cloudflare, it is 1.1, and so how they are using the same IP address? That means they are doing the Anycast. So same IP address is assigned to multiple DNS servers. So whoever one of them will receive the traffic based on the end user, whoever is the nearest one, he will actually receive the request and he will reply. If the nearest one is down, the traffic will be sent to the one who is like next to it. So same we have the concept here, because we have multiple links in the core, and our core network we want to have the redundancy. So that's why we have grouped 4 routers with these 4 routers with one Anycast SID. That means any one of them, if from we talk about from this side, if this router is going to send traffic to A2 or A1, the objective is to reach to the other side. So either A1 receive the traffic or A2 receive the traffic, they will be able to pass it on. because within the core you want to quickly send the traffic and you want to have the maximum high availability. So in order to achieve that, we are going to use the APNIC ACID. So other than that, we also need to we should keep in mind, like all these nodes, they will have their individual node SIDs as well. So that means they will have maybe I can say 101, 102, 103, 104 as an individual node, but as a group they have 100. Similar for the other 4 nodes, the APNIC SID for them is 200, but they will have individual node SIDs as well. That means if you want to send just traffic to A1 and there is another network attached here, so there is no need to send to A2. You can directly send to A1. Then you have to use the node SID. But if you want to, the objective is to send traffic across the 2 nodes, then you can use the APNIC SID. So all the routers, they are going to advertise the APNIC SID, and it is same prefix with the same SID value. That means they are going to advertise this prefix this IP address 203.0.113.1, and the APNIC SID will be 100. So similar to like the example for the Google DNS or for Cloudflare DNS. So the same IP address, you will have the same SID, because obviously the SID is representing a IP destination. It could be IPv6 or IPv4. So what is our objective in this case? All traffic from P1 to P3 should traverse the top plane. So top plane is, what is our top plane in this case? So we are saying the traffic should go from these 4 set of nodes, and the path should be from P1 to P3. So it should go from here and finally reach to P3. So we are not specifying it go to A1 or A2. It should only travel through these 4 routers, and we do not want the traffic to go from the bottom 4 routers, because this is our top, like upper maybe north part, and this is our south part, and P1 also has the path available from P2 to R2 and then from R4 towards P3. But we do not want to use this path, we want to use the upper path. So in this case, we can use the APNIC SID for these 4 nodes. So this is our desired path. So let's see how the traffic will be forwarded. So in this case, P1, it will force the packet to P3 to go via the APNIC group A. So what is the list of segments that it needs to push? So it will put the VPN label, which is 10234, and then the label which is for the node SID for P3. In this case it is 113, because the index here it would be 13, and it will add to the base, so it will become 113. So we have to put 113, and then after that we need to put the APNIC SID for these 4 routers. So APNIC SID for these 4 routers is 100. So the traffic from P1, it will go to R1, and from there the R1 it will forward towards the A1 or A2 depending on the metric here. It can send on any of the link. Then once they receive it, since they can identify top label is the same as the local APNIC SID, it will pop it and forward the traffic towards A3. So since once A3 will receive, the top label is different than the local label, so it will just swap it and it will forward towards R3. Once R3 receive it based on the shortest path, it will forward towards the P3, swap, and then forward. Once P3 receive, again it will pop the both labels and send the traffic towards the destination. So another use case for this could be where you have we have maybe if I have another CE here, this is our CE router, maybe C2, and we have another router here which is like CE1. Okay, and this is connected with P1 and P2, and this is connected with both of the P's here. So now these two P1 and P2, they can provide the connectivity to C1. So that means we can configure ANICA SID for both of them. So we can put these two routers in one group, and we can put these two routers in one group. So in this case, if they need to, the traffic from C1 need to go to C2 or from C1 to C2, instead of sending to individual router, we can use the ANICA SID. Let's say we say ANICA SID in this case is 400 here, and here we have maybe 300. So this ANICA SID will be advertised to all the nodes in the middle. So once the traffic will come, we will push the VPN label, which could be 1, 2, 3, 4, and then we will put the top label, which will be 400. Okay, and traffic will go to R1 or R2, and after that, let's suppose this time it uses this path, it reaches to here. It will, based on the top label, it will just swap forward towards R4. R4 receives, it will be like 400, and then 1 to 4, this will be the label, and so based on the top label, it will just swap and forward towards the P2 or P3. Since it has shortest path, maybe it will prefer this path, so it will send towards P4. P4 will receive it and send towards C2. But what if it happen like C3, it is down due to some reason, there is power outage or some hardware failure. So in that case, the traffic will go to P3 and towards the customer, and there will be no interruption. So this will be the advantage for the ANICA SID. Like if the node, one of the node which is part of that ANICA SID, it is down, the other nodes, they can receive the traffic and they can forward it. So this will help us to provide the high availability services to the customer, where you have the, maybe you want to achieve 100% SLA or 4 nines or 5 nines, you have the SLA and you want to achieve that. Because then you have to consider there should not be any single point of failure in your network, and you have like multiple links, multiple nodes, the devices are in different racks, you have redundancy at the power level, you have redundancy at the link level, you have redundancy at the node level. So the next we have is the traffic engineering. Although we have discussed some sort of traffic engineering part, but now we will see in more detail how we can do the traffic engineering. But should not we go for the lab first? I think it's better we go for the lab and then we continue for the presentation, because you will have the chance to see what we have discussed so far, how we can configure that, and how we can like provide the service or configure the segment routing and use it to reach from one node to another node, or we can carry the customer traffic as well. So we have to go back to the yesterday lab those someone who has already completed their lab, you can resume from there. If you have not done, then you have to do the step 1 and step 2 again. If your time was finished, then you have to consider that. So how you need to go to the lab? You will go to the course material page. If you do not already have the link, you can just type this link, APNIC academy.apnic.net. And the first thing that you need to do is login. If you have not created your login, you can register it using the email address you have. It will send a code on your email address, and then you need to use that. But if you have already done, then you just need to provide your password and continue. Okay, so I was assuming that my display, you was able to see the screen, but so you have to go to the academy.apnic.net. Once you go to this URL, then you need to log in. Since I have already logged in, if you do not have an account, you need to register using your email address. Then you see courses, events. So you need to go to the events, upcoming event, then go to this introduction to SDN. Click on it and it will open a new page. Sometimes few people, they are wondering, we are unable to see the slides here. Actually, you have to click on this link, course material, because this will by default it will just show you the overview. You have to click on this course material, and then you will be able to see the detail for each day. So we have to move down, and you will be able to see here the segment routing MPLS lab, although it is same lab which we have here. So you need to open it in a new tab. You sometimes even select the data center, like if you are you are into the close to other region, or you think your connectivity is better towards Europe, so then you can select the other data center, because then it will use the other than the, like by default is Singapore, but other we have option Europe and North America. I think North America is not desirable, that will be bit far away, so Singapore makes sense because it would be maybe 100 milliseconds from here. So if you have saved the lab, you will see the option instead of launch, you will see the continue. But if you have not done like me, then you will see the launch lab option. You have to click on launch, and before that also do not forget to enable the pop-up. So in case you have Windows, you will see a rectangle here, and you need to click and allow the pop-up from the Academy. So can everyone please launch the lab? If you have a laptop, you can please log in and open so we can do it together. So in the meanwhile, I was able to fix the few of the mistakes we have in the lab instruction. So I will upload the latest file as well. I think there was so earlier this was missing, like .10, it should be .10 because we have specified this interface. So this was missing yesterday, which was creating the issue. So I will just upload this, and then you will be able to see the latest lab guide. So has everyone been able to log into the lab? If you have not launched your lab, can you please launch the lab meanwhile? So once you go to the this segment routing lab, so you have to use this resource. You can see SR MPLS lab, you have to click on it, and then it will open up in a new window. So we have to, if you have not done part 1, part 2, then you need to do part 1 and part 2, but if you have already saved, then you can continue, go to part 3 and continue from there. You can use then the start from the segment routing. But since I have not in my case saved it, so I have to quickly go through the part 1 and part 2. So first I have to, in part 1 we have the MPLS and LDP needs to be enabled. So I will take this configuration and do on the router 1 on each of the router. So if you need to do, please do it quickly. Just copy it from here. Go back to your other screen. So for those people who were not here yesterday or day before yesterday, once you are into the lab, you see the CLI, you see the instruction. Normally we follow the instruction we have on the right hand side, but in this case we have customized the instruction. That's why I am not following these instructions. But by default on all other labs we follow the instruction we have here. But in this case we are not following. You can see here we have the host, which is the device on which is showing me the desktop, and here I have list of routers R1, R2, R3, R4, and this is the topology or diagram for these routers. So I have to configure each one of these routers. We have already the IP address configured, we have already the OSPF configured. Since I am modifying some configuration between R1 and R2 to create a CE. So actually I am going to treat R2 as a CE and as a core router as well. So just to treat it as a CE, I have created here a sub interface. So that's the modified configuration which I need to do. The rest of configuration is already there. I can let me show you as well. And similar, the other CE I am creating here between R4 and R6. So I am using a sub interface between them to simulate a CE. Normally we have another router or PC connected here, but then I have to modify all the topology. Since due to some constraint we cannot do that, so that's why I'm using a sub interface to simulate a CE. So in order to access the router, you have to double click. Like if I double click on R2, then the interface for R2 will come up, and you have to click on the window for the router and then press enter. You will get the login prompt. Password is Cisco. For all the routers the password is same. And once using this password, once you logged in, you have the root access. That means you do not need another password to go to the configuration mode, because some of the Cisco router has this thing like configuration mode has a different password. So once I have logged into the router, I can see what is the existing configuration I have, like the interface IP addresses. So show IP interface brief. This will show me the name of the interface, IP address, state, and the protocol state and the VRF number. By default, all of the interface, they are in the default VRF. That's mean the global routing table we have. So you can see here the link which I have to modify is this G00 tetra 0, and I am going to create a sub interface for the transport, like for the core link, and one sub interface for the CE. So that is the change I need to do. So I will go back to the guide. So this is the configuration for the R1. So what I am doing, I am going to the main interface, removing the IP address, creating two sub interface. One is for the transport, another one is for the CE. So in normal scenario you do not need to do this, is just in our lab case. And then since I have removed the IP address from the main interface, then I have to enable the OSPF on the sub interface where I have given the IP address. So let's copy and go back to your router. In order to paste, you have to click on this lightning button and type text, type clipboard text, paste here. See if you see any mistake or if some text is missing, because sometimes what it will do, it will remove this slash, put 000 like this. Sometime when you are pasting, it actually removes or change some of the instruction. Then you have to just like take a look on all the commands. If it makes sense, then you can press OK. I will just remove this commit so you can see what is the why we need the commit. So once you paste, it goes to the interface, this interface, then goes to, do I need to increase the font? So you can see I went to the interface levels, then I give the command no IP address, remove the IP address, created the sub interface, given the VLAN 10 and given the IP address. Because I want to have two interfaces, so I have to create two VLANs as well, so the router can understand like which VLAN it needs to use for which sub interface. And then I creating another sub interface, this is VLAN 20, and I'm removing the IP address in case of this sub interface because we need to configure this sub interface under the VRF. So to configure any interface under VRF, first it should not have any IP address. After that, I am going to enable the OSPF on the sub interface, which is for the core, part of the core network, and I have like listed this interface, so OSPF knows it needs to establish the neighbor relationship over this interface. Before doing this, even you can check what is your current neighbor relationship. You can use the command do show neighbor, show OSPF neighbor and BR. So it will give you the list of neighbor, like router R1 has neighbor relationship with router R2 and router R3. So you can give the root command when you are doing some configuration, it will move you to the root level instead of to the interface or the protocol level. Then give the show command, it will show you what is the configuration that you are going to change. So this shows the new configuration that is going to take place for this section. So now we need to commit the configuration, because by doing the configuration it automatically does not apply it. You have to commit it, and you can see there are options to even commit it. You can label it, even you can display commit failure immediately. That's mean if you will give this command, if there will be any error, it will give you the detail of the error. So since there was no syntax error, or we have not given any command which the router does not support or the feature, so it has accepted the configuration. So if I check it again, the show OSPF neighbor, now you can see I have only one neighbor instead of two, because I have changed the configuration on router 1, I need to change the configuration on router 2 as well. So I will go back to the guide, from there copy the configuration for the router 2. Okay, so another configuration that we need to do for the router 1 is to enable the LDP on the new sub interface and enable NDP on the interface which is connected from R1 to R3, because this will enable the label distribution. So I have to go back to R1 and paste the new configuration. So this is actually just the comments, this is not the command, I can remove it. Even if I send, the router will just not accept it, but there will be no action. So I'm going to define the MPLS label range, for which is 24,000 to 2499. That's mean if the MPLS need to use the labels, it can use this range. Because we have given a higher range to avoid the conflict with segment routing, later on we need to enable the segment routing as well. So I need to specify the router ID, so this router could be identified using this IP address. Let's do the commit, show MPLS LDP neighbors. So you can see it is not showing any neighbor because I have just configured one router. But it is showing me the interfaces where I have enabled the LDP, like the sub interface 00 and the main interface. So here I have the sub interface, here I have the main interface. It's showing me the config is yes, enabled, yes, yes. That's mean it's enabled, but other side is not configured, that's why session is down. Okay, let's go back and copy the configuration for R2. So this is the configuration that I need to apply for the R2. I will go back to R2 router, and now I need to go to the configuration mode and then paste the new configuration. Just have a look what you are doing. We are going to enable the config mode, and then to this interface, remove IP address, create sub interface. Here we are giving the IP address on the sub interface as well, because this will be not the VRF, a normal interface. Then enabling the OSPF on the new sub interface we have, and committing the change. Then we are again going to the configuration mode and then enabling the LDP. Because we were already in the configuration mode, so it has given just this error. So invalid, because we are at the same level and we are trying to asking him to go to this level. So once you have done the commit and you will come out of the configuration mode, you can again check your OSPF neighbor, show OSPF neighbor. So you can see in this case now we have the neighbor relationship with the router 1 and the time it's up since 21 seconds. For the other routers it's also showing the OSPF neighbor relationship because they were already configured. We did some configuration change between R1 and R2, that's why we have to adjust the configuration on the interface level, on the OSPF level, and now our session is up. So that's mean R2 is done as well. Now move on to R3. Copy the configuration for the R3. In case of R3 we are just enabling the LDP because there is no change in OSPF. OSPF is already pre-configured. So I will access the R3 router. First I need to log in. When you are pasting the configuration, just be careful like which router you are doing the configuration and you are on the same router. Otherwise you will end up doing the configuration for router R3 on R2, and this actually can in actual network can result in some downtime as well. But since this is lab, there will be no impact, but then you have to spend time to remove the configuration and do the right configuration. Okay, it has committed, so you can check just that your OSPF neighbors should already be up. PF neighbor, you can see the time is just giving us the indication like since when we launched the lab. So it's already 18 minutes past, so this was up since 14 minutes. But show MPLS LDP neighbors. Will I be able to see any LDP neighbor? Because I have just enabled the LDP, so it's showing me the two neighbors towards R1 and R2. So from R3 towards R2 and R1, because on these two we have enabled the LDP, so it's showing me the neighbor relationship is up since 32 seconds. Okay, let's go back quickly to R4. On R4 again we have a little more configuration than the other router, because here we are again creating the sub interface to simulate the CE router. So another way is like if you have already your screen filled up, you can minimize and minimize the devices which you do not need anymore. So we need to go to R4. Just be careful like on which router you are doing the configuration, you should be on the same router. Okay, so creating sub interface, assigning IP address, enabling OSPF on the interface, then defining the range for the MPLS LDP and enabling LDP on different interfaces. So these are the different tasks that we are doing. So you can see the moment we configure LDP, it is already up within like since last 6 seconds. So now I need to go to R5. Just minimize this R4, go to R5. Okay, paste the configuration for R5. I only need to enable the LDP for the label distribution. So before I commit this configuration, just check do you have any LDP related configuration. So if you want to check, do show run MPLS LDP. So it is showing there is no LDP configuration. Because of that we will not see any neighbor relationship for the LDP as well. Even if you check show MPLS LDP interfaces, like on which interface you have enabled LDP, it is showing empty because we have not enabled this protocol on this router. So once I will commit this, then the LDP will be enabled. So this is how we are saying your router ID will be 1.5 and enabled LDP on these interfaces, and use this label range to assign the labels. So I will do commit show MPLS LDP neighbor. So you can see it is showing me the LDP neighbors and showing us the information related to as well. If you want to reduce this information, you can use the BR command. So the other neighbors, it has 3, 4 and 5. So 5 is here with 4 and 3 and 2, it has the neighbor relationship. But 6, since we have not configured, that's why it's not showing 6 as its neighbor. But we have, if we check the show LDP interfaces, we have already enabled the LDP on the interface towards the R6 as well, which is our I think GI000. So if you see, we have already enabled on this interface as well. On other interfaces we have the neighbor relationship, but not on this one. So now I need to go and copy the configuration for R6. Go to R6 and then paste the configuration. If I now go back to R5, so you will be able to see the R6 as a neighbor as well in 13 seconds. So now our whole network is configured for the LDP, so it can carry the like it can use the MPLS to forward the traffic, but using LDP, not the segment routing. So now we need to so if I want to check the forwarding table, so I can use the command show MPLS LDP forwarding. So it will show me the what is the table mapping, like the incoming and outgoing label mapping. So you can see here, if I want to reach to router 1, okay, so my outgoing label, it could be 2400 or 24009, and incoming label is 24009. Similar for the from R5, since these router R4, R2 and R3, they are directly connected, that's why there is no outgoing label, there is only incoming label. If I go to R6, then it will be maybe more clear. Show MPLS LDP forwarding. So here you can see, if I want to reach to R1, I can use the, so you can see if I need to reach to router 1, I can use the label. My incoming label could be 24003 and outgoing label will be 24009. For R2, it could be the outgoing label will be 24005, and for R3 it will be 24003. But for R4 and R5, from R6 perspective, since they are directly connected, so it does not need to use a label to send traffic towards them, because it will just pop the label and use the implicit null, that means send the label 3 instead of the actual label. Even we can check our connectivity from R1 to R6 or from R6 to any of these router. You can use the ping command, ping MPLS LDP IPv4, then you have to specify the IP address 172.168.1.1 and the mask as well. So you can see it is showing us successful. That means we can reach to from R6 to R1 using the MPLS label. And if you want to see what are the label it is taking, it is using, so you can use the traceroute MPLS IPv4 172.16.1.1/32. So you can see it used the outgoing label 2400 8 and it send the traffic towards 10466. So where is the interface 10466? So this interface, if you see the IP address 10466 is on this side, 4 is on other side. So it used this outgoing interface and used the label 24008. So once it reached to here, then this router R4, this has used the label swap 24008 with 2400. Once it reached to R2 with 2400, since it is directly connected with R1, it does not need to include the label. It will use the PHP and it will pop the label and send traffic towards R1. Even you can check there is a way to force the label. You can check like force explicit null, that's mean you want to include the label and ask the router to do not pop the label. So in that case it will keep this exp00. If we do not use this force label, let's see what it shows. It will not, I think, show the exp. So you can see it is now showing just 00, but if we include force, then it keep the label 0 as well. So in order to show like we have a VPN customer, we will use the sub interface. We will configure the R1 and R2 as a BGP neighbor, and then see, they will be able to exchange the route from the CE, which is we are saying like connected behind R1 we have a CE and behind R6 we have a CE. So in order to provide the VPN service, we have to configure MPBGP, multi-protocol BGP, and carry the VPN v4 unicast address family in it. So we go back to the lab guide and see the next. We need to configure the P1, which is R1, and what we need to do, enable the BGP. So we have to specify router BGP 100. This is 100 is the autonomous number, like it needs to use. Address family VPN v4 unicast. Then the neighbor, this is R6 IP, the remote neighbor IP, remote AS number, update source, and the address family that they need to exchange with each other. So let's copy this configuration. The other configuration that we need to do is the create the VRF under the BGP. We will create the VRF. RD is used to distinguish the routes. Like for each VPN instance, you will use a different RD. So the IP prefixes remain separate from the other VPN customers. Like maybe if you have more than one VPN customer, this RD value is actually keep it separate from the other customers routes. The address family, and we are saying redistribute static. So you can include here redistribute connected as well, because then it will be able to redistribute the connected IP address. The other thing we are saying, okay, we need to export the routes. That means whatever the routes we will receive from the other neighbors, we have to use the import them and export our routes. So we have to include this tag 100 and then colon 100. This is a like community to add to your routes, so the other side P knows like what to do with these routes. Then we need to include the sub interface under the VRF. This is our CE interface, which we are saying connected on our PE side. So from PE side we need to bring it under the VRF, so it become part of this VPN. Let's put this configuration, go back to R1. So you have to log in again. I think it just timed out. So these are the comments, you can exclude them, or if they are there it will not make any difference. So we have to include here redistribute connected as well. So it is showing some error, I will see. It is not showing any configuration, it seems like there is some error in the configuration. I will try to paste it again and see. Config T router BGP100 address family. Okay, so it has accepted this configuration. So it is giving me error here. Maybe sometime when we paste, due to the ASCII characters, this sometime create an issue if there was any space here. So I think I have to type it manually. So I have to go to VRF VPN A. First need to go to the BGP level. Then VRF VPN A. Okay, I think this is outside the BGP maybe. So actually this part where we are giving the error, it's outside the BGP. So we have to, so now it's accepting it because it was on a different level, that's why it was not showing the command accordingly. So if I go back, so ideally after this commit, even I'm saying VRF VPN, since it's on the BGP level, so it's adding the command under BGP, but first you need to exit and go to the global level, not under the BGP, then it will accept. So how this, so you can just type and exit here after this configuration, then it will accept. Okay, so we are able to add the BGP session, add the VRF and configure the interface under the VRF. Let's do a commit. Show BGP VPN v4 unicast summary. So this will show us the session. So it is showing us the session is in active state since we have just configured the one side. So I need to add the configuration for the R6. So I have to specify root after this. So it does not add the configuration at the, so why it has not accepted, because it was not, it was timed out. I need to log in. So now you can see the neighbor relationship is up since like last 12 seconds, and we have received the one prefix as well. So far we have been able to just reach to the previous lab where we left yesterday. So if you want to check what are the VPN routes that you have received, so you can check show VRF VPN, name of the VRF, show route VRF. So you can see there is one route we have learned from the other side, which is the R1, and this is our local route we have. So where our C is, it's on the, even we can test connectivity from within the VRF. So if I am on the P router, I need to test connectivity. I will do the use the command ping, name of the VRF, VPN A, then destination IP address 10.10.1, because 1 we have configured here under the VRF. I have to, I think, specify the source. It's showing some issue. I have to check what is the, let me ping the local IP. Okay, if I go back to the other side, Okay, so here you see I am not seeing any route. The route is 0. If I check show VRF, show route, VRF VPN A, I do not see the remote side route because I have not redistributed the connected route. So I have to go to R6 and redistribute the connected route. So under the BGP level for the VRF, so I need to give the command redistribute static connected, so it can redistribute the connected link. Router BGP100, then I need to go to the VRF VPNA, to the address family IPv4 unicast, because this is within the VRF, that's why we are saying IPv4 unicast. This is outside the VRF, that's why we have the VPN v4 address family, because this is used to carry the VPN routes. But this is like within the VRF for the C to PE, there we are specifying the IPv4 address family, and redistribute connected, so it can redistribute the 10 network which is connected here. So once we will give this command, then it will be able to redistribute the IP address on this interface. So we do not have this IP address on the R1 side. You can see R1 has only 10 network. It is not able to receive this 20 from the other side. That is the reason we are unable to reach from the R6 to R1 for the VPN route. So once I commit this, then we go back to R1 and you will see we have a route here. So now it is able to have a route from R6 through the BGP, and this is showing us the time since it is there. So if you want to check the, you can see here it is showing us the route 20.20.20.4, and this is reachable via this next hop. So for 20.20, the next hop on R1 is R6. So this is how R1 knows if it needs to reach to this 20 network, it needs to send towards the traffic towards R6, not towards R2 or R3. Obviously, once traffic will go to R2, the next hop is R6, R2 and R3, they will automatically forward traffic towards the next hop, and then next hop will send towards R6. So earlier we were trying to ping from here, and now you can see I can reach from 20.20.20.1 to 10.10.1. And if I take a trace route, VRF VPN A, so you can see there are two labels. So this is your transport label and this is your service label, the VPN label, and VPN label is staying the same, only the transport label is changing. Even you can send more than one packet. By default it sent 3, you can send even 5 or 4 packets. In that case you can see here the time. So it is sending 4 packets. For first packet it took 29 milliseconds, then 19, 9 and 19. So this is a lab environment, so the latency could be variable. Otherwise normally it remain consistent. So why the VPN label is not changing? Because this is for the VPN and middle router will not touch it, and it will remain the same. Only the transport label will keep on changing. So let's move on to the next part we have. So after that we have achieved the connectivity using MPLS label. So there are few commands more which I would suggest you can execute them and see what is the more information you can see regarding the labels as well. Due to the time I will not be able to go through them. So we have to now enable the segment routing. How we enable the segment routing? We go to we will enable the MPLS traffic engineering. This is for the traffic engineering. You need to give this command go to global mode and MPLS traffic engineering. In order to enable the segment routing, you have to go to the OSPF level and then give this command segment routing global block and the range for your block. Okay, let's give this range on the R1. So we have specified the range. What else we need to do? We need to specify the loopback interface, and under the OSPF we need to enable the traffic engineering as well. and on the loopback 0 interface we need to specify our prefix it, and we are saying absolute value. So that's mean it will not be based on the index. We are already giving him use the absolute value of 16001. The other way is you specify prefix it index, and then it will use the calculated based on the sRGB range. Okay, so let's go back. So these were not the command, these were comments, that's why it's showing error. So these were only the comments. So again the prefix it, what is the option we have? You can see we can specify absolute or we can specify the index. So if you specify index, then it will use that index and calculate the sRGB. Otherwise you can specify the absolute value 16001, then it will use this value. So once we have done this, we can check the show MPLS forwarding label 16001. So you can see here it has created one label using OSPF. The others are all LDP based, and this one is OSPF based, because this is we are using the segment routing. Another thing you can use here, see here the BGP VPN v4. This is your label for the VPN traffic. If whatever the customer you will enable, it will add one label for each of the customer as well. So let's quickly complete the configuration for other routers. So it's very easy since we have a small topology. So you can just see we will be changing this absolute value, and the rest is going to be same for all the routers. So one way is like you can copy this configuration and keep on changing the absolute value for all the router and paste it quickly. But we have to switch the routers. Okay, let's I'm on R2 and 16002. Let's go to R3 and first login, because it has timed out. So for R3 we will change this number to 16003. The rest is same, loopback. There is no IP address or something like that, and since range is same, so it can accept it. Now I will go to R4. For R4 I will have absolute value of 16004. So I will change it to 4. For R5 it will be 16005. So this number I will change to 5. Let's now go to R6, and before I commit the configuration we will see the label mapping first. Okay, do show MPLS label. So you can see here we are not seeing any label from other routers, but if I go to R5, show MPLS label table, so I can see this 16000 OSPF1. I can see the OSPF has some other labels, so these are based on the adjacencies, and this is for the segment routing nodes. So if I will go back to the R6, show so we'll see how we can verify the configuration. So once we have completed this configuration, then you need to verify. So how we can verify the configuration? We can go to the OSPF level, okay, and we can check this command, show OSPF database OPAQ area advertising router. So we can specify the IP address of the router and see what is the segment routing information it is advertising. The other command we can use is to verify prefix SIDs, which are like transported by OSPF, show OSPF SID database, and show MPLS forwarding you can use to verify the MPLS forwarding plane and verify the label allocated locally. You can see the show route detail as well. So we'll execute these commands one by one. So first I will go to the R1, and there I will check the what is. So if I am on the same router, then I have to use the command self, because let me see what is the self originator. So then it will show what is the information itself it is originating. So it should be brief. So here you can see the MPLS-T router ID. So you can see the router ID. It is the same router ID which we have used since we are using the loopback 0. And you can see the LSA type. I hope everyone knows the LSA, or should I explain a little bit about it? So actually when you run the OSPF protocol, each router, it actually does not advertise any routes. It advertises the link state advertisement information. We say LSA types. So it could be LSA type 1, type 2, type 3, type 4, type 5, 6, 7 as well. So each router, when it advertises its own routing information in OSPF, we say LSA type 1. So what information it includes in LSA type 1? Its own loopback and the links which are connected with it. So it just includes this information in a packet which we say LSA and send to its neighbors. So its neighbor actually receive this information. They make a topology and link state database, and based on that they create the map of the whole network or the domain they are part of. Like it will be specific to area. So in OSPF, each router, they will have the same topology information. They will know who is connected on the left, right, up, down, and the router behind its neighbor. So they have the complete map of the topology. So that's we say the LSA type. But here the type is OPAQ area. This is type 10 for the segment routing, and we can see the T. It is also showing the MPLS-T since we have enabled the MPLS traffic engineering. So it is showing us the router ID for that and the number of links we have. The next command, even we can check for the other routers. Instead of self originate, if I will give the advertising router and I specify the IP address of the other router like R1, so it will give me the information regarding the R1. So if you will execute this command for the other router, you will be able to see. Next we want to see the OSPF SID database. So we can give the command show OSPF SID, and you can specify a question marks OSPF. It was SID or SID database? Yeah, SID database. So I have to see why it is not showing. Maybe we are missing some commands or something. Okay, so we can go for the break. Meanwhile, I will see why it is not showing the required information. And in the next session will be after the lunch break. So after the lunch break, we will resume at 1:30, and then we will continue from here.